All right, let's jump right in. Today, we're going to talk about something that sounds simple, but is actually a famous mathematical head scratcher, the birthday paradox. And I'm telling you, the answer is probably going to make you second guess your own brain. So picture this. I'll make you a bed. You're in a room, people are milling around. How many folks do we need to get in that room to have a better than 50-50 shot, a better than even chance that at least two of them share the exact same birthday? Just take a guess. What does your gut say? 100? Maybe 180? The answer is just 23. Yep, that's it. You only need 23 people in a room to make it more likely than not that two of them have the same birthday. I know, right? That sounds, well, it sounds completely wrong. Your intuition is probably screaming that the number should be way, way bigger. And you're not alone. There's a reason they call this a paradox. So let's pull this thing apart piece by piece and figure out why our intuition gets so tripped up here.
Okay, so the very first trick to understanding this is to completely flip the problem on its head. Instead of trying to calculate the odds of two people matching, which gets messy really fast, it's way, way easier to figure out the odds of the exact opposite happening. We're going to think backwards.
So here's where our brains make the first mistake. We hear the question and we instinctively think, what are the odds that someone in this room has my birthday? But that's not the question. The real question is about any two people in the group having a match. It could be me and you, or it could be those two people over there in the corner. We have to check every single possible pairing. And because we have to check every pair, trying to calculate the odds of a match directly is a huge headache. You'd have to say, what are the odds this pair matches, or that pair matches, or that other pair? It's just too much. It is so much simpler to ask the opposite question. What are the odds that nobody shares a birthday? And this strategy actually has a name. It's called the complement method. Basically, you think of success as finding a birthday match, and failure is finding zero matches. So if we can figure out the probability of total failure, no matches at all, we can just subtract that from 100% to find the odds of success. It's a really neat little mathematical trick. So let's start with the absolute simplest case. It's just you and me. My birthday is on one specific day. For your birthday not to match mine, it just needs to be on any of the other 364 days of the year. The chances of that are 364 divided by 365, which comes out to a massive 99.73%. So, yeah, it is almost a dead certainty that any two random people do not share a birthday. And this right here is why our intuition gets it so wrong. We're only thinking about one single pair. Okay, so if the odds are so ridiculously low for just one pair, how on earth do we get to 50% so quickly? Well, that brings us to the second part of the puzzle, and this is where the real magic happens. We have to count all the possible pairs. And this, right here, is the absolute heart of the paradox. The key isn't the 23 people. It's the shocking number of unique pairs you can make from those 23 people. Because as you add more people to a group, the number of potential pairs doesn't just go up, it explodes. That's the secret sauce. Now, to get the exact number, we use a handy little tool from math called the combination formula. Don't worry about memorizing it. All you need to know is n is the total number of people we have, in our case 23, and r is the size of the group we're making, which is always going to be 2 for a pair. This formula just does the heavy lifting of counting every single unique duo for us. All right, so we've got our two main tools ready to go, thinking backwards and counting the pairs. Now, let's put it all together and finally crack this thing for our group of 23 people. So let's actually use that formula. We've got our 23 people. How many different two-person handshakes are possible in that room? The answer is a whopping 253. Just let that sink in for a second. With only 23 people, you get 253 unique pairs. Every single one of those is a new chance, a new roll of the dice to find a birthday match. Suddenly, 23 people doesn't feel like such a small group anymore, does it? So with 253 chances for a match, what are the odds we strike out on all of them? To figure that out, we can calculate the odds that every single person has a unique birthday as they join the group one by one. Okay, so imagine the first person walks in. Their birthday could be anything. The second person who walks in has a 364 out of 365 chance of not matching. Now, for the third person to not match either of the first two, there are only 363 days left. You see how this works? We just keep multiplying these shrinking fractions for all 23 people. And when you crunch all those numbers, the final probability comes out to about 0.493. So that means there's only a 49.3% chance that absolutely nobody in a group of 23 shares a birthday. We are right on the knife's edge of that 50-50 mark. And now for the final beautiful step. Remember our little trick from the beginning? If the chance of failure, meaning no matches, is 49.3%, what's the chance of success? We just subtract it from 1, and there you have it, 50.7%. In a room of just 23 people, there is a greater than 50% chance that at least 2 of them share a birthday. And just like that, the paradox is solved. So now that we've cracked the code for 23 people, it gets really fun when you see how fast these odds ramp up as you change the size of the group. Just look at this. With a small group of 10 people, you get 45 pairs, and the chance of a match is pretty low, just under 12%. We've already seen that 23 people gets you over the 50% line. But look what happens when you jump to a group of 70 people. The number of pairs just skyrockets to over 2,400, and the probability of a match becomes 99.9%. At that point, it's basically a guarantee. So, if you're going to remember one thing from all of this, let it be this. In any group or network, the number of potential connections, the pairs, grows way, way faster than the number of individuals. It's a fundamental principle that shows up everywhere, not just in birthdays. And really, that's what's so cool about this paradox. It's a perfect example of how our gut feelings about probability can be seriously, deeply flawed. And it kind of makes you wonder, right? If our brains can get this wrong, what other, much more important odds are we completely misjudging in our lives every single day?